So your voice is breaking. Excuse me, sir. Your voice is breaking.
For integration and differentiation, if you said that they'll send you one unit, right? Did they send you anything? Did they ask you to record it like quantum kinetics, kinetics. Maybe okay, maybe you're looking for two dimensions. The second week. That's right. Okay, fine. Here, you could share with them the recording for integration differentiation. Just send it again. They need that picture. Integration differentiation. Differentiation, sir, I told you last week, right?
Last week
He told
already
that he has uploaded things. Just check it out. Integration and differentiation case giving a recorded lecture. Thank you. Okay. Hello, can you hear me, Ananya?
Yes, sir. Now I can hear you.
Now you can?
Yes, sir.
Okay, fine. Yeah, because I put on the mic right now. So okay. See, guys, any doubts, any questions? Send it in the group. We won't have enough time. We only have classes for 1.5 hours, right? So it doesn't make sense here you come and ask and something and right, you send it to me before. If what we can do is maybe during the week I can solve it and I can send it down. So that becomes easier for you because everyone's time is saved, right? All right, is that cool? Fine. Okay, so go through stuff on math. Do you remember what we did? Okay, concepts are clear now. Mainly concepts have to be clear. That is the most important thing. Okay, fine. So, do you guys remember? Do you guys know the three equations that you have for motion in a straight line? Do you guys know the three equations? No, no, no. We have this one, right? So do you know that particular equation? A x power plus b is equal to u plus x. Not half 80. That's 80. The second equation. 80 square. Okay. And the final one is c square what is possible? Oh, the screen is not okay. So same equations. Note it down. Go through it. Let's take a look at it. Initial velocity plus acceleration. Yeah. Second one is the create okay. Yeah, what is that? Okay, this much is clear to you, right? So now we're going to look at how we can maybe design things may get started getting like complex from here. You have to try and understand this problem. This might be slightly easy. I'll make it as easy as possible. And then we because tricky stuff, not difficult stuff, tricky stuff. Okay. More than I think in your CBSE, more than checking your understanding, they like to play tricks of the brain. So that's how the diagrams are. Okay, fine. So we looked at yeah. We looked at our graph velocity versus time graph. Let me make this bigger. Okay, pay attention, note down later. No problem. Understand that. What will be on our y-axis? Velocity versus time. Velocity. And on our x-axis. Fine. Suppose now my graph looks something like this. Okay, it's a straight line. Let me try to make it straighter. Alright. So that means that my velocity has started at point here, right? The moment we change, the velocity is not start at zero, start from specific value. So there will be basic value. It is not start from zero. And This value, let me call it E naught, or let me call it U to avoid confusion. Yes. This is some value U, initial velocity. Alright. And then this is the dotted line. This some dotted. Okay. So, do we remember what the slope of this? And okay, so then what will be the value of this? Can anyone tell me? Along x-axis. So it will be 0, 3. Right? And if this point, if I call it some value p, then this particular value inside the bracket is p, this is u. So what is this going to be? V minus? Correct? Are we able to understand this? It's very basic. This is my initial velocity u minus velocity v. So and then okay, fine. So remember we discussed slope in the last class, correct? And we what is slope? Come on, tell me what is slope? It is a constant, fine. Now, but what is the value? Slope is given by dy by dx, correct? Dy by dx, right? So dy means any value on the y-axis. Dx is x any value on whatever is on it. So what is it? Okay. So what is my? It's going to be my t. P I can call it, right? So that's velocity by dt. And what is dv by dt? Exactly. dv by dt, just change in the velocity by not forget time. Change the velocity for big time. So what is that? Acceleration. It's nothing but acceleration. Correct? So this value, my slope is given by d by d, which is nothing but acceleration. And I can write this same thing as e minus u by d. That is because that's the change in velocity, right? Right. And this is going to be equal to what? Acceleration k. Everybody knows this. Here's the question. So I can move t to the other side, right? And I have v minus u equal to 8, right? Or I will have p equal to 2 plus p. Our first equation comes from here. Equation of you can know this now. Okay. We'll start from here. You can start writing from. Which one? The next slide or the previous? So. I'll go to the previous slide, okay? So that the others can follow this, but on that we couldn't follow. Is it no? What? Something. Maybe. It's one. But if you are only that Alright? Most of your teachers, I think they don't go into so much detail of this thing. But if you understand these concepts, you can do anything in the world. Okay, I'll move to the next slide. Or what you know what? From here, try to arrive at it by using arrive at you the written it, written everything, copy, then we'll move to the next one. Yeah. Okay, so you got how the first equation comes, right? Everybody is clear? Now we look again at the same plot. Displacement? Same graph, but displacement. No. Same. You just see what is how we do. This velocity is the remember it said for a velocity versus time graph, the area if I calculate, it gives me the displacement. Okay, so this is where we start becoming smart and we do some clever things. So can you tell me area of okay, we can well so like from the same graph, the area of the graph we do you got it. We had introduced the last. Don't restrict the number. Set of numbers we use. Okay, and so denote has a particular meaning. U means initial velocity, V means final velocity. So we are not using numbers, but if you get a that formula, what is that for the formula? So it is going to be a distinction. Come on, don't you can use okay. But there is a simple way. This is square and this is so what do you do? Area of the square. It is the formula for area of the square. No, right? No, same thing. No, yeah. You need to see. So what is it? Basically, I what we cannot take as a square what how base is right now what is but for the below we are doing that like side by side. So consider it together. So the idea square basically the meaning would be what if this is square the meaning would be that the value of t would be 5 the value of t would be 5 that's all in math is the same t and u they define your type of quantity like 5 kg you can't say kg per over if it is square that would this has to be 5 So there is a trick. But good try. Yeah. So come on, guys. Our expression should be right as is equal to half what? A minus 2 T plus 2T. Clear? So in the previous one, does anybody remember this? This relation is true for all, right? Or I think the better way to write this is, can we say that WKD meaning that? Okay. Yeah, then do it, man. Okay. So then, can we say that P minus U is equal to 80? And can you put that? Yes. Yes. Just showing it to you now.
So from working up the NSU, then after that
Yes, sir. No problem. This is a separate one. Okay. This is not a complication. We know that. And this what we got? We got the from the previous relation. I'm borrowing this part. Okay. Are you clear with this? I'm borrowing this part and I'm saying, see, we know this, and it's a universal truth. dV by dt is the universal truth, that is acceleration. And we put nothing but T minus U divided by T into area. So we can not into area, is equal to area. For small things you don't calculate. I'm telling it now. So, yeah. So this is just to take V minus is equal to dt. You're getting the idea? Instead of this V minus U, this V minus U is equal to dt. So this V minus is equal to dt. Put on here. Getting it? This much is clear to you? So it will be what? AD square plus UT. Or in other words, your formula UT plus and this here in T. Clear? Okay? And square is the type of rectangle. You're confused about TPT or TET. Because I think you're trying to derive another equation. But now the concept is clear. Okay. Okay, so are we clear about these two equations from where we got from how we got these two equations? Right? So I think we'll move on to the third one. But for the third one, what we will do is we will borrow or this equation thing. Okay, you can write first, second, and third separate. Okay, I hope you can do that. First one you write one or something like that, and underline your final equation. For the second one, this is the approach. Underline your final equation. Now for the third one, you write separately. Observe and manage time to solve it. Again, S is equal to, what is that? E minus U, T plus UT. Same equation as before. I'll separate these two. I'll write half VT. You know, opening the brackets, you know, right? Minus it will be UT by 2 plus UT. Correct? Okay. Now there is a UT by 2 half plus UT. Let's take this column quite directly. Yeah. 1 by 2 bracket V minus U T plus U T. Same equation. I will put the bracket. If whenever I am moving to bracket, part of that. Should be half V half U T. That one will be U T plus U T like that. This plus this UT by 2. That is, if I minus half plus half, what will be? Sorry, minus half plus 1 will be minus half plus 1 or 1 minus half. Getting the idea? Both are you are getting the idea? Okay? Or you can read. All right. So, did you guys write it here? Okay, I'll do one more step and let me see if your few more steps are make sense or not. You see. And now I can take the half outside. You did this, and what are you going to get? U plus B into T. Right? So what is this? Half. Sorry. So what is U plus P by T? Initial velocity plus final velocity divided by T. I'm taking the average. Exactly. I can call it P average. Is this much clear? See, when I'm talking, you listen to me. Okay. U plus U. Or here, no? You. Okay. Till here, everybody has arrived now. So, do we remember something from previous situation? The same equation that we have used everywhere. We borrowed one from the first one, right? Yeah. So we have borrowed this equation, right? From the first one. It's a common thing. Right? Same thing we use in the second to derive the second one. You brought it again. And for the third one, what we are going to do is we'll use the same one again. That was what is it? U minus U by T. Right? But here I don't want A, I want T. Okay. So this T, can I put it here? Yeah, exactly. Yeah. Sorry, you didn't bad or anything, right? Which bag do you want to go? This one only. Take your time, understand, okay? Awesome, man. So can you try to solve and get that kind of equation? Did you get it? Okay, can you try it? So I'll tell you. Okay. So this T, if you put out here, you're gonna get T average. T multiplied by T. Fine. T plus Q by T. So I'm sorry, T by T. Come on. What was the average? Just previous step. We found what is average velocity. Correct, exactly. P plus P by 2. So what did we substitute as the value for P? P minus 2 by what? 8. So now what happens?
So we are substituting this value also from the first equation, right?
Correct. So take a look. P plus 2, 2, 3. So what is A plus B to A minus B? You see that earlier A plus B into A. So it will be what? B square 5B. So then can I then write this as 2A with the other side? What will I get? 2A S was that is equal to B square minus B square. Exactly, that's your equation, right? That's your third equation, correct? Can you write it? Did you write it? Note it down? Note it down. Or you can write it just like this. Take 2 minutes, go through this, understand. So can we do the same thing? Can do it. Right? Right? But if too much or they have given my okay. I have done it in a way that is understandable for all of you, and it is easy. And then, and if you write this, I don't believe that anyone should say they have written something wrong. Okay, because it gives you the answer, it doesn't write it. Just that when you see, I'm just giving you the equation, but when you write in a exam, this is not how you write. I hope you understand that. You write things like you mentioned, we consider this, the how I'm explaining, you say, you know, right now the textbook actually consider a velocity versus time. The way of writing is different. And we must understand, make things clear to you if you understand. But once you understand, should be different. And it's easier. Consider an velocity system graph. The initial velocity will be u. The final velocity will be v. Consider this particular portion where the difference will be v minus u. Correct? This can be the slope of the graph can be given by dy by dt. You have to explain your now, let me see what I can do. Graphical method to prove about equations is what is given. Graphical method to prove the equations. That is given in your book. Okay. Yeah, then. That is right. This is wrong. Ask your teacher if you want to say about and not mean we don't do this also it can be done. And if when you have learned it and the solution is right there, you can write it. If you don't understand it, you can always come back. Okay, because I'm not sure if integration has been done for you or not. I don't know. They have decided as uploaded those videos for you to understand. You go through it, you do it. I believe you can do it, and they have explained the solution. Okay, if you're out, you come back to me. I can explain. Is everything clear to you? Fine. So now we will. So these three equations we are going to use to solve a bunch of problems. Okay, that clear? So we're going to start with problems now, and we'll do. Ananya, is this clear to you? What was done till now?
Yes, sir.
Okay, one. Yeah. So. Okay. So note this down. Okay. A 100-meter, a 100-meter sprinter, a 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square. I repeat, a 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square, up to 3/4 of the total run. Up to 3/4 of the total run. And covers the last quarter with uniform speed. I repeat, a 100-meter sprinter increases her speed from rest uniformly at the rate of 1 meter per second square up to 3/4 of the total run and covers the last quarter with uniform speed. How much time does she take to cover the first half? How much time does she take to cover the first half? I repeat, how much time does she take to cover the first half of the second half of the run? The first half of the second half of the run. The first half of the second half of the run. Third quarter. Yes, third quarter. Third quarter. And also find the total time. Okay. Find the total time. So, like any problem, you first try to draw things out. Quarter, you understand quarter, right? 3/4, you basically divide by 4. 1/4. And third quarter means, yeah, 3/4. Total time. 3/4 is 3/4. So, always the best way is to visually draw something, draw the lines. Write down what is given to you. It will, if you want, I will give you just a clue that the easier way to do it would be obviously divided into quarters, but we know different time spans, right? If we see, we know that the total is into 100 feet. Yes, correct. So since they've asked 3/4, it makes sense to divide this into T1, which is half, okay, and T2, which is 3/4, and we can call this T3. Just use this method to do things. So for T1, you can write what is S1 displacement, you know what that is. For T2, you know what is S2, for T3, you know what is S3, the displacement for each one. And you know also that the acceleration A, it remains constant for 1 meter per yeah, that is the acceleration till 3/4, okay, till T2. Then acceleration, then what it says, then the speed is uniform speed. So that is acceleration is acceleration is a change in velocity. If your velocity is same, there is no change, then acceleration is zero. Okay. First, what you can do is you can change slightly tricky. So dear, try. Do it for T1 first. Use some equation, find out what you can get. Find out if you can get the time of T1 time. Okay. See which equations will suit you well. For T1, T2, and T3, I'll just write down all the values I know. I know that S1 is 50 meters up here. For T2 minus 50 75 meters. For T3 minus it will be 100 meters. Okay. My acceleration is 1 meter per second square. This is the data that I have. Okay. One thing I can try is for I can say T1. I can find T1. And which equation can you use? Correct. Okay.
So for the initial velocity,
No. Initially, see, when you are running, she's running a race. Let's see what it says. You guys, after like that, I get excited.
T1
100? 80 square, if you forget to take the root.
Okay.
That would get a 0, man. That silly thing would get a 0. The answer would be wrong. One minute, you just figure it out. Okay. Did you guys get it? Okay, good. One minute. But did you understand this equation we can use? Is that clear to you? No, right? So let me just tell you. There are, so what you do is first you take the data that you give. Okay. And what is your thank you. So, that is what this is what you get. Maximum form to get one particular result. Even EU. So is this equation satisfying? Because displacement I know, initial velocity 0 I know, my acceleration I know at that period of time. That I can find out using this because everything else is correct. You're getting something, right? Yeah. So for what we consider, no, we have to consider 50.
So again, the
then the three months. It was really like, they gave the question for 3 quarters.
3/4 of the total running is the distance.
3 quarters. What is
I'm not able to follow. Sorry.
so for example, 3 quarters.
Correct.
So you know,
Correct. It represents the speed, as so just give it to them. That is simple. So what is the doubt?
so
Yeah, yeah, that is what. That is. Yeah, that is. 15, Okay, how do you solve the? Yeah. Uh, So for 20. If there is a. So it was 12.25. Right there is 12.25. That's what you'll get.
sir, 50 liters, like in the online it comes to you, we get 50 liters, 50 square per two.
Oh,
Yeah.
yeah, correct. Yeah, correct. So solve it. See, find what the
Master, yeah.
is your acceleration. Is there any- That's it. And so you're just substituting the value, okay? But what is one? Yeah, so my C, my S1 is what 50. My U will be what initial value is 0. So even if whatever is the it doesn't matter. Plus half A, I can write A will be 1 into P.
So, even then,
Correct. Okay. So what will be one will come it will be correct. So we should apply that. 1
P for the
seconds, okay? Always try to use time into second. Okay. Can you do the same equation for T2? Can we do the same? Do that for
same equation for what?
T2. Yeah, very coming. Except for the last portion, what did you do?
P3.
I
computed. So it's a credit one.
got 14 points. come around 14.29 or something like that, but you must be correct. Okay, I've done it differently. We've done it differently, but that's right. So you have gone to total time this way, right? But can you find the third quarter? Yeah, that's what you are able to do that. 2.25. Yeah, yeah. For what I did was, let them come and get. Yeah.
Sir, T2, what is for an answer?
Yeah. Okay. That's it. So, but can you are you able to find the okay? Because otherwise you won't be able to subtract them. You getting it? No? So the idea is listen, both of you. This value we have got 10, no? 10. Right? This one 150. If you don't convert 150 in terms of 10, how do you subtract 100? So you have to simplify it. But for the sake of speed, right now, I know the value, I can tell you, just write that down, but figure that out. Okay, you need to be good at doing this. The value you get is 12.25. Alright. For the sake of saving time,
For taking the point.
yes, yes. 12.25. Use the same equation for T3. Actually, that same equation, what do you do? Okay. E up. Just as normal. Okay. No, you cannot use that equation. Why can we not use? Can somebody one minute? The speed. I'll tell it. Buddy. So what happens is you cannot use the same equation for the T3. Reason is they say that does the acceleration immediately throughout. T3 is what? T3 is T3 but we know that one two what speed is not changing. That means the acceleration is zero. Acceleration is what rate of change of speed. The speed is not changing, it's constant. Means it is going constant rate. That's it. How about the next what with the acceleration? Huh? No, it cannot. That equation is invalid here. That equation cannot be used. A some value has to be there, something like that. But it cannot be used because the value is not the same. But this is one value. So what we can do is listen, both of you, all of you. For this part, what is that part called? My last portion, last quarter, exactly. So that is my T3 minus T2. Correct? We'll use the most beautiful equation of all when the velocity is constant. That is time is equal to distance by or speed is equal to distance by time. Same thing. Understood? But it's constant. I can actually use that. I know my distance is 25 because it's the last quarter. Not using those equations. We use a different approach. You understood that, no? Time is that. But how to find that? That equation we cannot use because the acceleration is changing again, it's becoming different. But getting it, no? For one half it is different, another half it is different. I cannot use. Okay. Good question. Coming there, 1 minute. So you got this equation? So that uniform speed. So do we know or final what speed this person is running at? We don't know.
So we can't.
Okay. Okay. Yeah, we do not know. Correct. So what we can do is for this one, if I've done this, what we can do is we can try. We know each square.
One of the being covered in the both all the
Third quarter means buddy. The last or let's say it's saying for first 3 quarters, it's saying what from rest is uniform at the rate of uniform acceleration means uniform is constant. Here, no? So uniform acceleration. What is acceleration? The speed is so constant, not quarter time. With time, right? Second, exactly. Constant acceleration. means the speed right? And then we go what is the acceleration? We know. Okay. Velocity is defined. So I can say speed. This acceleration is zero. But the velocity is uniform. Same, uniform, constant. Now the car is accelerating at 5 meters per second. Means every second, 5 meters is velocity. Each first time we are 5 meters. The second is speed is that is change. That is not for each side is change in that clearly it is without for finding about the distribution and what is the okay. This concept of speed is without proper understanding is solved. Okay. Okay. So we know one equation are here, right? We know this, right? It's one of the equations. B square minus C square is equal to 2 base, right? So can we do this? Can we just do this? Did you do it? No. What I'm telling you is keep your pattern. The idea is hello, yeah.
I got the answer.
Yeah, excellent, good. I just explained it to the people are here, okay?
Okay.
If you put it very good. Listen, there are 3 different equations. These are what we can have in one person. Okay. Problem here is I don't know what is the velocity. Correct, no? We derived. Correct. But finding the finite velocity at an angle, that will become the getting it? The V2 of this part will remain constant velocity. Clear? Okay, that's right. So now what I want to find, I want to find the final velocity. Because from here it is not changing, it is the same. Clear? So my V2 I am able to V square. So can you do this?
So here I will do one.
Correct. Because here inside of the whole throughout this whole A remains constant. A value A, if it was changing, the equation would be simple. Only three equations, right? Only three. Nothing to, no headache to worry about, nothing to worry about. What did, can you come again? Yeah, it's the same thing, but it's the correct. Initial velocity of this zero is
So V square is equal to 1
exactly
V.
one. So now can we use this? We find T3 minus T2. Come on.
25 by 12 is
0.25.
make it. Yeah.
2.0. Okay. So T3 minus yeah, you guys clear? Okay, do it. Short.
It's 2.04 across.
Correct. Awesome. Good job.
Yeah. Okay.
Mathematics.
You say we have
Okay, T3 minus T2, now what is the value? One, let us, this what is T3 minus T2? What is T3 minus T2? 2 point?
29
Okay, and what is the Hmm.
14 point 28. 14 point
Yes.
14. Yeah, I know the same track of this big one.
That for that. Okay.
They are total.
These are total time. And can we find what is their third quarter goal last, right? So they want
First 200.
so they first half of second half. First half of second half, what does that mean?
Second half is
A2 minus to the direct
2 minus
yes.
2 minus
Done. Okay. Fine. 2.25 what it is. Okay. Always units. Without units, no meaning. 2 of what? Okay. Should we do one more problem? Maybe it will help you guys settle in a bit. Okay. But okay. Then note it down. Tell me. Yeah, tell me. Yeah, yeah. Okay, okay, right. Yeah, Nanya, good job. Okay. So the next question very short, finish it off in 2 minutes. Okay. Come on. A bullet moving with a velocity, a bullet moving with a velocity of 10 meters per second. I repeat, a bullet moving with a velocity of 10 meters per second hits the wooden plank. Hits the wooden plank. A-N-K. A bullet moving with a velocity of 10 meters per second hits the wooden plank. Then the bullet is stopped. The bullet is stopped. I repeat, the bullet is stopped when it penetrates. The bullet is stopped when it penetrates the plank. I repeat, the bullet is stopped when it penetrates the plank 20 centimeter deep.
20 centimeter what?
Deep, deep,
Deep.
deep, deep, D-E-E-P.
Yeah.
Deep. Okay. Calculate the retardation. Calculate the retardation of the bullet. Okay. right? And that's all it's done. It is acceleration. Acceleration we say when it is speed is increasing. Retardation is decreasing. That's all.
So you will not account for
Acceleration is happening. Retardation means velocity is decreasing.
So finally, you have to use
Yeah. Initial zero, correct. Because it hits the Planck stops. So units, just look at the unit. Something has to be converted here. Correct. It is in centimeter and everything else is in meters, right? So we'll try to reconvert it in centimeter. Correct. So that's the distance. That means how much inside, no? That is the distance.
like there's a man and go to the part.
Correct, exactly. So the idea is this is the plan, right? We want telling bullet is coming, it is going inside. Okay, it is going in this direction. You are able to understand this, right? So the bullet is going in this direction. It will go maybe till here it will go. So this is my
How like
you don't need time. What are they asked?
why have
So is there some equation? Is there some equation that tells in which see first write what is given to you?
you can be
U is there, correct? U is given, B is given 0. Then what else? Our distance is or displacement S is given. So find which equation and what is asked? A, right?
okay.
So do you know which equation is fitting all of these things together?
Where what do you where
Correct.
so you
Maybe 2,500 meters. Yes. 500.
and x is 0.2
Yes. B square
so we
2AS. Okay.
so we is 0 so it is 975
B is 0 minus 10 squared.
equal to in accelerated mind of s is 1. So it is 100
Half minus 0.4. A is equal to just calculate and recheck. Okay, 1 minute. Okay, that is correct. That has been printing error also. And so you guys are right and it is fine. So this is when we can go to the next one. So what you have noticed is that the sign is so the sign so this okay, think it is better to do one more problem. Okay, it's okay if we go slower on the concept, we'll do some problems. Okay. Fine. Okay, so this one is clear. Everybody has done this. Very direct. Okay. So next one, come on. Two trains A and B, 100 kilometers apart. Two trains A and B, 100 kilometers apart, are traveling towards each other. I repeat, two trains A and B, 100 kilometers apart, are traveling towards each other with starting speeds of 50 kilometers per hour for both. The train A is accelerating. The train A is accelerating at 18 kilometers per hour square, and B is decelerating at 18 kilometers per hour square.
Decelerating or retarding?
Decelerating is retarding. Okay. Decelerating at 18 kilometers per hour square.
It is decelerating in the same way.
Yeah, with the same value, 18 kilometers per hour square. Find the distance. Find the distance from the initial position of A of the point
Okay.
of the point when the trains cross each other or the engines cross each other. Should I repeat the question or everybody got it? So 1 minute, take a step back, stop. You don't have to start solving immediately. Always take a good 30 seconds to see the problem and understand how you will do it. If you simply start to make it stuck and that will scare you because why what am I doing? You take a step back and you relax and you look at the question, you see what it is. Okay, and draw this nice diagram. You can also draw this, right? So I know A, I know B, and you will from 50 kilometers per hour. So, but can I say that there are two situations are here? See, right? So I can write in terms of, I can write a situation for A, and I can write a situation for B, correct? Okay, so can you guys write for me, right? This is U1 and A1. But
So that by writing A to F,
did you get it, buddy? U2 will be minus 1 because it is decelerating. Decelerating means retardation. Okay, same thing. So write this much, write these values, and then stop and let me. I want to give you guys. I want you to understand who you write. Okay, written this right, the values.
U1,
Yeah,
U1,
U1, U2 is given, right? Both are 50 kilometers per hour, right? Yeah, yeah. Plus here plus 18, here minus 18. Okay. Right distance curve now. So whenever the SI units are different, we try to simplify them and bring them in terms of meters, seconds. Correct? We need to do that here. Why? Because all the same. It is not in meters. You know, generally, I would want to convert it from kilometer to meter. If it is in centimeter, also I want to make it meter, kilometer to meter. If it is not, I want to make it in seconds. If it is in minute also, we like to make it in seconds. Generally, correct. But here, all are in the same units. So I can proceed with the equation for all the same units. So if I take time, that much is clear here. If I get velocity to be, if I get acceleration to be, because the units are written constant. So now see, we read the question again and see that the distance is 10 kilometers apart, and what we want, sorry, 100 kilometers apart. And what is it that we want? We want to find the distance at the position of A at a point where they cross each other. So at one point of time, they are starting at the same time and they are crossing each other a particular distance. So let's say they cross each other at this point, okay? And I call this E1, I call this E2.
E1 plus E2.
That is, this is the time, this is time that was distinct.
No. After we find the distance from the equation,
Correct.
why are we taking that?
Yeah, the reason, exactly. The reason I'm telling you guys is I want you to think in this, think one,
Because the speed,
one, they are particular point. So, if let's say I start from Velachery, you start from Mungala. Okay, and we will measure this, we will meet each other, we will cross each other again. So the idea is that the time I take from we both start and we both is my T1 equal to what we do. Wherever if I start Velachery, T-buddy. Let's do this Velachery and all. This is your A, this is your B. Both are starting. Doesn't matter. I start to solve. Maybe the so I think
okay.
from where what is this going to do? I do the same. First forwarding. Getting the idea? So the time is remaining. So both of the times are same. So can we use something like that? Yeah. So using this knowledge not made, but you told me something very interesting and very useful. What did no? You told me something very okay. So this here the thing is fine. Yes, and that you have told me something very interesting. So E1 is equal to E2. This is something we can say, and I call it T because it doesn't matter both are the same. And you told me something about this. So
The distance from the point A to the point where they meet.
S1 plus S2. That's all. The sum, you told me it should be divided in terms of distance, which is correct. And we will do that. But the reason I mentioned time is because you understand this concept. It is very important. Otherwise, what you have, you have D1 on here, you have D2 on here, replace by U. I have D1 also, I have D2 also, how to solve? Correct? But now both of them are equal. So that simplifies your process. So can you tell me which equations we can use? We both know the sequence to be the path. You think he is right? Okay, you go through it. Just go through the equation. Go through the equation. You should know these equations by heart. Look at the lip of your tongue.
So no, we don't have X. So B equals
That's okay. What do you think? What do you guys think?
because final velocity will be zero.
No, they don't stop. They just cross each other. You don't know final velocity.
So final
How final velocity is equal to?
I think every equal using the constante.
It is okay, fine.
still we don't have X.
Yeah, but what I will do is I'm going to do this, right? 1 plus half A1 square plus 2B plus half A2 square is equal to 100. Why do I need this?
60 will be given, right?
Huh?
60 equals to 50 given. Common value.
Yes, because both of their signs are same. Others, what would have happened? You want, yes, so right, fine. Perfect. Don't have to do that. Don't do that now. It will, it's very easy, very direct. Ah, ah, plus that is interesting, right? One.
So in 1 hour, we substitute
We don't know if it is what. There's a starting value of the speed. You can use speed and distance only if the velocity is constant. It's not constant. See,
so we can substitute we can
yeah, which one do you get as?
When given the two or and form. So we think that difference is A. So can the point is form. A1
Just substitute values to become very clear. It is in two steps you get. It's very easy. Okay, look at me.
no,
You don't have anything different. Look at me. What is U value? Tell me. So what is U? U1 50 T plus half. What is the A1? Okay, 80 T square plus what is U2? What is U2, man? And then plus correct. So I can just write minus 1 instead of writing plus 3. Okay, minus correct. So I'm equal to 100. Here plus here minus cancel 0.
And
You should always take time to think, okay,
no, like, one thing I think, okay, even if we take the PPT, like, if we can also, we need to take the long and okay, separate. So, we have enough into it. Okay. So the whole
one, let me come over there, okay?
left.
You wanted to bring A outside, right? What do you mean?
The whole, property, give a part of the property.
Okay, already now,
We could take P from P.
if I yes, so with this laptop is away, the laptop is playing and we are also past the time and to go further we need to go into the next topic. So we'll start the discussion tomorrow on the next topic. Okay,
But we didn't find it.
do it. Listen, S is equal to S is equal to U plus AD. T you know now. Sorry, yeah. S is equal to UD plus half AD square, sorry. So you do that. U1 you know, time you know now, acceleration you know. Anyway, it was given to you. Just a direct substitution. Yeah. Yeah, you can send that. Hey Ananya, were you able to do this?
Yes, sir.
Okay, are you able to understand the concept, Ananya?
Yes, sir. It's clear.
You are able to get what is happening, right?
Yes, sir. I sent the answers for the previous
I
question.
saw that. I'm just asking you.
Okay, sir.
Yeah, everything is clear, Ananya.
Yes, sir.
If you have any doubt, you can always stop me and you can ask me. Okay.
Okay.
Okay. Chalo then. See you in the next class. See you tomorrow.
Thank you.
Yeah.
Yes, you have the daily.
So, guys, this is starting to make you know. So, okay, simply don't done. See what is that's all. If it's not this, it's that. It's not this, it's something maybe from either the time you need attention or this So on tomorrow, what are you going to do and come home? Properly. Okay, learn that. Okay. Sir,